Hi friends, we are going through the number system in class 9. So in the previous class we mainly classified the real numbers as rational and irrational, and rational number covers integers, whole numbers and natural numbers, and the other arm of real number is irrational. We know all the real numbers can be plotted on a number line, so irrational numbers also can be plotted on a number line. Today we are discussing how to plot irrational number on a number line. Irrational numbers, yesterday we discussed as root of non-perfect squares comes under irrational numbers. Can you plot root 1 on a number line? It is very easy. Root 1 is 1 itself. So root 1 is 1. This is root 1. And root 4 you can plot on number line as 2. Root 9 you can plot on number line as 3. Root 16 as 4. Root 25. Root 36, like that. No need of any effort to take on plotting the perfect square roots on number line. This we can write like this also. The number line can be rewritten like this also. No harm in writing like this. This point 1 is root 1. Point 2 is root 4. No harm, no? Clear. So, what about root 2 and root 3? I'll tell you how to plot root 2 on the number line step by step. Okay. Take a pencil or pen, whatever. Then mark this 0 point as O and mark this 1 as M. Now what is OM? OM is 1, that is root 1. So we have to know root 2. So draw a perpendicular with protractor and all. You know how to use protractor. Keep the 0 on the point M and measure the 90 degree. You have to mark a point here and join with scale. Measure 1 centimeter on this line. So you made a perpendicular from M, that is MP. Then join this OP. This distance OP will be root 2. The process is not over. Why? Root 2, now we measured the value root 2, but root 2 we have to plot on the number line. So take the compass and with the center as O and radius are OQ, draw an arc on the right side of the number line. Likewise. Now this point will be root 2. So now mark the root. We marked root 2 on the number line. Any doubt? You can comment below. Then how to calculate root 3 and plot it on the number line? Again with protractor. Here, how to keep protractor? Make a perpendicular for OQ. Make a perpendicular for OP, not OQ, sorry, OP. Place the 0 of the protractor on P and mark the 90 point here and join measuring 1 unit. This also 1 centimeter and this also 1. So you made a perpendicular for OP and mark the point as Q. Join OQ. This OQ will be your root 3. Now not finished. With center as O and radius RQ. And draw a arc on the right side of the number line. That point is root 3. Yesterday we saw the values of root 2 as 1.414, etc. Likewise, root 3 as 1.765 extra like that. So, no need to write like that. We can plot as root 3, root 2 itself on number line. So, likewise, once more I will explain. Draw the number line. Mark the 0 point as O and mark the point 1 as M. Then from the point M, draw a perpendicular to the number line measuring unit distance, 1 centimeter distance, and mark that point as P. Connect OP. That OP will be your root 2, and to plot the root 2 on the number line, take the compass with center O and radius OP. Draw an arc and cut the right side of the number line. Not cut here. This will be the point root 2. And if you want to find root 3, then make a perpendicular to OP. Take care. OP you are making perpendicular, not to OM. OP make perpendicular with 1 centimeter distance. Mark that point Q and join OQ. That distance will be root 3. Then take the compass with the center O and radius Q. You have to draw the arc to cut on the right side of the number line. That point will be root 3. Now I will show you how to plot root 5 on the number line. You may be thinking that take this as O and this is M and make perpendicular here, mark root 2, then perpendicular root 3, then perpendicular root 4, then perpendicular root 5, like that. But there is no need of drawing like that. There is an easy way. We know root 5. Before root 5 what comes? Root 4. So the value of root 5 will be more than root 4. More than root 4 means we know root 4 is 2. So root 5 will be a value greater than 2. So whichever number it is given to plot on the number line, just check the perfect square below it. For 5, the perfect square is 4. Then take the square root of that perfect square, that we know 2. So in previous plotting root 3 and root 2, we took 1 and drew perpendicular from 1. But here we have to draw perpendicular 1 centimeter from 2. Then join this line. This may be M and this may be P. So OP will be your root 5. Root 6, make perpendicular to OP just 1 centimeter, maybe R or whatever. Mark R, then you will get root 6. So to plot root 5, you have to keep the center as O and radius OP. This is root 5. So if you want root 6, this is root 6. This is root 5 and this is root 6. Likewise. If somebody asks you to plot the root 17 on the number line, then what will you do? Which is the just below perfect square of 17? That is 16. What is the square root of 16? That is 4. So, how will you do? Don't make perpendicular from 1. Don't take perpendicular from 2. From where you will take perpendicular? Mark this as M. Mark the point O as 0. Then make 1 centimeter perpendicular from M. Mark the point P. This is 1 centimeter and this is 4 centimeter. Then join this O to P. That will be your root 17. If you want to easy, we will be thinking that root 2, root 3, root 4 like that. We have to draw a spiral like that, perpendicular. No need of like that. Just take the number and find the just below perfect square and the square root of that will be your point of drawing perpendicular. But for root 18, you have to draw perpendicular from OP, then join OR. This will be your root 18. For root 19 also like that, root 20 like that, root 21 like that, 22, 23, 24, but 25 we know it is this is itself, root 25. And for 26 it is easy way, draw OM, point M in 5, draw perpendicular and join OM will be root 26. You know Pythagoras, great mathematician Pythagoras explained how to plot the irrational numbers on number line. So how did he do in long before that we can check. For example, we took root 5. How we plotted? The 0 point we marked it as O, and root 5 means just below perfect square is 4. Square root of 4 is 2, and made a perpendicular of 1 centimeter, and that point is, this point is M and that point is P. So OM is square root of 4 and this is 1 centimeter, and connected OP, that is square root of 5. You have learned it. So take the triangle OPM. You know that we have took 90 degree from here. So this is a 90 degree triangle OMP. Applying Pythagoras theorem for OP. OP square equal to OM square plus MP square. OM we know, OM is this distance, that is 2. This is MP is 1. 1 square plus 2 square is OP square. So OP square equal to 4 plus 1, here 5. Therefore we got OP as root 5. Clear?